Hi, I'm Lisa Nichols, and in this video I'd like to show you how to run a vacuum distillation or a reduced pressure distillation. And you might want to do this if the substance that you're trying to purify has a very high boiling point, like 150 degrees Celsius or higher. If you would try to distill that in a normal way, heating at those high temperatures, you might cause those compounds to decompose. So by doing the distillation under a lower pressure, you actually lower the boiling point, which means you'll be able to distill them at a lower temperature, and then they're less likely to decompose. I'm going to set up everything in the fume hood because working under a vacuum is actually quite dangerous, and so in the hood you have a more protected environment. And I'm going to be heating my mixture using a heating mantle, so I'll first connect that to a variac and get that preheating off to the side. Here's my vacuum pump that I'm going to use eventually, and here is the mixture that I want to distill. So for bump protection, you want to add a stir bar. You don't want to use boiling chips. Those don't work under vacuum. So you do have to use a stir bar. And then connect that to a ring stand over top of a stir plate. And if you have one available, it's real nice to use a lab jack underneath that stir plate. It just makes it really easy to raise and lower the stirring mechanism. To continue building my distillation apparatus, I'm next going to add a Claisen adapter. And this is absolutely necessary when you're working under a vacuum because the liquids are very prone to bumping. This piece of glassware prevents those bumps or those miniature explosions that happen inside the flask from ruining your distillate. And when you're connecting two pieces of glassware in a vacuum distillation, you want to make sure and grease all of the joints. So if you have a syringe that's full of grease, you can use that to really easily put little dots of grease on the top of one of the pieces of glassware. And don't use too much because you don't want it to contaminate your sample, but just put like a little couple dots on the top. And then when you stick that into the other piece of glassware and twist it around, you'll make a real nice greasy seal. And so that'll make it more airtight and more able to create a nice vacuum. Above the Claisen adapter, I'm next going to close this hole with a stopper. So I'll grease that and add that to my setup. And what comes next depends on whether I'm working with a large or a small scale. If I had quite a bit of liquid, I might set up a distillation in a normal way. Use one of those large condensers, attach a vacuum adapter, and that little nub on the vacuum adapter is where you're going to attach the vacuum. But I actually have a small amount of liquid here, so instead I'm going to use a short path distillation apparatus. So this is going to attach directly to the Claisen adapter. It's got the condenser and the vacuum adapter all fused together. Since that's coming next, I'm going to grease the joint to get that ready. And these little short path pieces of glassware, they're quite expensive. They're kind of breakable, but what's nice about them is that they're small and so good for small amounts of liquid. And also so many of the joints have been fused. So that means that there are fewer joints where you can have the atmosphere leak into your system. You can get a better vacuum. So it's easier to connect the condenser hoses before I've clamped the whole thing to the ring stand. So I'm going to wet the ends of the hoses and connect those onto the condenser. And then I'm going to put the lower end, connect that to the faucet, and have the higher end drain out. And next I would clamp that short path to a ring stand with a 3-fingered clamp. And then the awkward part, just keep everything loose and try to get that short path connected into the Claisen. Make many adjustments until you can get it lined up right. When they eventually meet and everything is looking right, you can secure the joints with yellow plastic clips. And next I'm going to connect a round bottom flask to the receiving end of the distillation. This is where I'm going to collect my distillate. So I first grease that joint and then attach a round bottom flask, and I can connect that with a plastic clip. And next we'll add a thermometer, and if you are using a short path piece of glassware, you have to use a thermometer with a ground glass joint. Grease that as well and stick that in the appropriate spot. Next I'm going to get my vacuum ready, and here's my vacuum pump. I'm going to first attach some thick tubing to the inlet of the pump, and I also happen to have a pressure gauge, which is optional, but helpful if you have one. I'm going to next connect that thick tubing to the vacuum adapter of the setup. That thermometer, though, is quite breakable, so I would temporarily take that out of the way and then connect the hose to the vacuum adapter, and then you can put the thermometer back. And everything should be set up now and is ready to go. So when you are ready to start, then you can turn on the water and get water flowing through the condenser. You then want to turn on the stirring mechanism. Make sure that stir bar is going nice and controllably. You may have to adjust your stir plate. It seems to work the best if it's positioned right in the middle of the stir plate. And then you don't heat it first. Before you heat it, that's when you're then going to turn on the vacuum. So you turn on the vacuum pump. The pressure is going to lower dramatically. We're going to see that on the pressure gauge. It just went down quickly. And so now you've removed the atmosphere. You have a low pressure inside of your system. That's when it can be dangerous. So I like to then lower the fume hood sash so that you're now working behind it. So if there was an implosion, you hopefully wouldn't get hurt. So when the pressure is lowered, you might notice some bubbles even right away. Those would be from any low boiling contaminants or impurities. They can boil even at room temperature. When everything seems to be going smoothly and it's no longer bubbling, now I could start heating my sample. So if you have a lab jack, you could lower down the stir plate to make room, and then you can insert your preheated heating mantle into the spot, raise the lab jack, and you start heating your sample. Again, I would recommend to lower the fume hood sash so that you're working from behind that safely as much as possible. And once you start heating it, here is something that is very likely going to happen. You're going to get moments where the liquid is going to bump into the Claisen adapter. So the liquid starts to boil, and instead of those bubbles coming out very nicely and controllably, they erupt very aggressively and they jump out into the Claisen adapter. I mean, that is what the Claisen adapter is for. It's a preventative measure so that when it does bump, that it doesn't spill out over the condenser and ruin the distillate. So it's okay, but you do want to get those bumps under control. So if it's doing it too much, just use the lab jack and lower the heat, or even turn down the heat and try to get the bumping controlled. If your distillation is taking too long and it doesn't seem to want to distill, what you might want to do is insulate the Claisen adapter. You can wrap it loosely with some aluminum foil, and the goal is to trap some air around that Claisen adapter so that it can stay hot enough for the vapors to continue to make their way toward the condenser. And here's what it might look like when it finally starts working. You'll see a lot of refluxing before the condenser, and then eventually you'll start seeing drips coming out into the receiving flask, and that's your distilled material. So when the drips are coming out quite consistently, you might want to look up at the thermometer and record that as your boiling point under the reduced pressure. And another thing to remember is that you never want to distill a flask to dryness. So do keep track of your distilling flask and make sure that there's still liquid there. Okay, let's say that we are done and we want to stop the distillation. What you don't do is you don't just go and turn off the vacuum. You want to make sure and cool down the system first. So you can lower your lab jack, take your heating mantle away, and then replace it with a container of water. Cool down your distilling flask, and at that point, now it's safe to reintroduce air into the system. You want to open the system, somewhere, like it's probably easy to do at the vacuum pump, reintroduce the air, notice how the pressure went way up again, and then you can turn off the vacuum.